Welcome to this outlier detection tutorial in Python. We are going to see what an outlier is and do a little exercise about it. Well, let's see what an outlier is. Before I start, we need to know what an outlier is, okay? So here we have our probability distribution graph that tells us how probable is some value of appearing in our sample. It's the behavior of the data, okay? So for example, if I don't know what is the favorite number of the people in the world. Okay, let's see this 4, and so the mean is going something like uh, near to 4. Okay, like 4.5 or 3.567. It is just a supposition. Okay, the important thing here is that we need to understand that the more far from the mean is a value, like here or here, like here or here, we need is the less probable of happening. Okay, so an outlier normally is defined as a abnormal data. This means that these have a low chance of happening. Oh, sorry. For example, taking back our example of the favorite numbers of the world, we say that 4 is probably our mean. A lot of people like 4. I like 4. But imagine if someone tells you that their favorite number is minus 10,000 and minus 10,001 and 1. This will be very strange because not a lot of people like 10,001. Okay? So we will be like here. And well, sorry, it will be here. Well, more like here, but the program doesn't let me to go like here, far away. Okay, this means the probability of happening is too low. So probably this means that or if a really special case or something bad happened also. So this means that this probably is a special case or something happened during the recollection of the sample. Maybe the one who wrote the number wrote it bad. Maybe it just one minus 10. It just was 11 and he mistake by this number minus 1001. Okay, so outliers really are data that is which is chance of happening is really low. Okay, yes, in some cases even this data have different distribution. For example, in the case that or all data recollected in a sample has a distribution like this, but some data that we recollect follows different distributions, and this can be by different things because it can be noise, or for example sensors that can take different values for different factors. Okay, but normally we say an example of this is how in the CERN they discover the Higgs boson. That is the probability of happening of that is really low. So it's like 5 standard deviations away from the mean. Now let's explain what means by clustering let's explain what means clustering based method for detecting outliers. Okay, just what is clustering? First of all, clustering is a method of grouping data by neighbors. For example, all data that if alike will be in the same neighbor. Just like this. So yeah, each with the same distribution in the net will be in the same neighbor. Well, I think you catch the idea. Well, the important here is that based in this idea, if we have an outlier, it will probably be high density zones, which our normal data will be. For example, here, 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 here. But outliers will be a really strange case, and even it will follow different distributions, so it probably will be a really dense or even single points like this or like this that they are really low compared to the certain data, or like this that could be outliers. So there are different methods for applying this technique. The one we are going to see here in this tutorial is called deep scan. In this example in Wikipedia, we can see that this algorithm follows 4 rules, and that it takes 2 parameters, that is the minimum points and the distance epsilon. Well, what this each parameter means? Mean points. Well, these are the minimum points necessary in order for a point to be considered a neighbor. And this parameter will determine if a point is a core point. We will see this later in the first rule. And the epsilon means that a point is connected if and only if the distance between them is equal or less than epsilon. Any greater than that won't be connected. For example, we can see that C and this dot won't be connected because the distance is greater than epsilon. Okay. The first rule talks about what defines a core point. A point, in order to be a core point, needs to fulfill this rule, that is, at least n mean points have to be within the distance of to be connected to this point, and it includes himself. So the number of points that need to be connected to a core point need to be the mean points that we specify minus 1, because we consider this as itself. So here in the example we can see that mean points is squared at 4. Here this is a core point because this 1, 2, 3, 4 are those 3 are within the distance e, equal or less than this distance, so it's considered a core point. In the other case here, this B is not considered a core point because it's just connected with this core point and just with that, and even if it was connected with another point, it won't be a core point, even that if just connected with 2 points directly. Okay. The same is for C. For here, this is a core point because it's connected with that and with that and with that and with that is more with 4 points, and with himself that it will be 5. So it fulfills. And the same with that and with that and with that. The second rule is about something what is considered directly reachable. That this means it has to be, the distance between them has to be equal or less than epsilon. like this. So this is reachable to this, and this to this. So this means that this is another rule. Just well, it's just logic. You can see that a point is directly reachable by a path if it connects with this and this and with this and with this. And I'll have to be core points. The path. So this object is connected with B by the path of this core point to A, to this core point, to this core point, to this core point. And the last rule is the most important because that says what are the outliers. The outliers are the ones that are not connected with the main cluster. Okay? The cluster here is defined by the distance that we say the epsilon and how it's connected, the node. But something that is really far or is greater than epsilon and doesn't connect with nothing of the neighbor here will be considered an outlier. This could be some cases in which they have really dense neighbor like that, and all these are within the epsilon distance for between them. But here can be a low density region that here are connected between them, but they are connected with the main cluster or the main clusters here. So these probably will be outliers. So the algorithm isn't hard to write, but in Python we are going to use a library that we call dbscan, and we just have to put the parameters in there. Okay, so it won't be hard. This would be probably funnier if we write this in C, but yeah. Let's go back to the code. All the models we are going to need for doing this exercise. We have pandas, we have for data manipulation, we have Seaborn and PyPlot for doing graphs, PyLab and Scarlin for the datasets. We're going to use the Iris dataset for doing this exercise. Why? Because I just import all the models we are going to need for this exercise. We have Pandas for data manipulation, Seaborn and Matplotlib for doing graphs, PyLab and Scarlin for the datasets, and important and our main library we are going to need is the deep scan and counter. These are important for this exercise because these are the and we have here the library necessary for doing the deep scan method. So this just have an inbuilt function that will help us to do this more easily. Now we are going to call the Iris dataset. So let's use Iris. And we have to use what this does is because the dataset of Iris from scalar now we convert that dataset to a pandas data frame, so we can easily manipulate. The data is for obtaining the data for this variable, that is where it loads the Iris dataset. And a lot of information. Well, we can see what Iris does have. Now we have a lot of bunch of things that we don't care about. Our web interest is about this array and converting this to a data frame. Well, I'm just going to skip this part and let's see the resultant code. We have import the iris dataset. We convert this to a pandas data frame and we create a new column called species. This column is based on the information that the dataset gives us. Well, now we have our data frame and we showcase the two first rows just to make sure that everything is okay. Here we can note that there are 4 variables, that it is sepal length, sepal width, and petal length, and petal width. So 2 widths and 2 lengths. And what type of species it is. In the documentation of this dataset, we can see what these numbers means. But this doesn't tell us much. So we're going to do some cleaning of this data. Well, of this data frame. Here we make the cleaning part. Everything just to simplify the names, because when we want to call the column of each data frame with this type of characters and spaces, it will be a problem. So we just replace the things that are useless for us, like space and parentheses and the centimeters unit. Well, here we just make a little function in order to replace the species number for the actual name of what it represented number. We just create the flower variable that is based on the information that the dataset gives us, and we just based on the value is here where we see that it's 0, 1, or 3. 1, 2, 3, 0, 1, and 2, 3 values. So if 0, it will be setosa. If it's 1, it will be, I don't remember what the other one were. But we have here, and we have here the species, and just we apply is just for replacing what the value of the rows. So we just expand this list. Oops. Yeah, I have to run this again. Yes, indeed, we did setosa. Let's check if everything is okay. Yes, Virginica, we have here. Yes, now we can continue to the next step. Yeah, I know it's a little boring, but we have to continue before doing the interesting part. Well, here we are going to now we want to save the important data for using in the DBS scan method, and in this case we just need the first 4 columns and all the rows. So in order to save that in a new data frame, we use ilog that it will just recollect the what we said. This receives 2 parameters, that is the number of rows we want and the index of the columns. So in this case, it means that we want all the rows and just the first 4 columns 1, 2, 3, 4, and then we have sorry, I just it's a memory table. What I did wrong? Sorry. Yes. Here we have we just eliminate a species. We can use data erase dot drop columns and it will be the same. We can see, but it's just more. It's the same, but we have to write more, so it's better this way. And this is going to be used in the DBS scan. Now we are going to the fun part. We are going to create a model, and just we have to call the function. So we don't have to write our own functions. That's why we use Python. Well, as we've seen before, DBS can receive two parameters that are the distance, the minimum distance that between each data point, and the minimum samples, that is where now we're going to the fun part, that is, well, now it's time for doing the TB scan model. Well, yeah, for taking outliers. As we seen before, the algorithm receives two parameters, the EPS, that is the minimum distance, well, the maximum distance in order to be considered neighborhood between points. What I refer is the next. We have point A and point B, and let's say our EPS distance is equal to 0.8, or what a little beautiful A. Well, doesn't matter. And in order to both of these points to be considered neighbors, we need that the distance has to be equal or less than this distance. If this point were a little farther than the circle position, I don't know, this 0.7 and this is 0.9. Now this wouldn't be they wouldn't be neighbors, but in this case they are, because it satisfies or dissatisfies this. So yeah, so funny. And while min samples is the minimum points that we need in order to form a density area. So in this case are 50. So if we have 3, these are in a density area, but if we have 15 points, it will be now we will consider density area. So yeah, that's it. And we here see blah 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 blah. We don't care about that. It's just for looking good. Well, what? Now we are going to analyze how the results of the DBS scan. So we create a variable outliers that is just a copy of the iris data frame. Why? Because we want to unmodified and just observe this. We don't want to do nothing with the original, so yeah. And it's just for didactic purpose. There is no necessity for doing this. So let's print some information that will be useful for us. Well, yeah, what this will give us is that there are three groups. They will print out the count of each column. So we have each column is for each group. And in this case, 0 and 1 form a group and -1 another. So we have 1, 0, and -1. And here is the count of each one. Here, given that this is based in Euclidean distance, the -1 are the outliers. So we can see here that of our data frame, we have 95 of the group 1, 50 of the group 0, and 5 outliers. So let's print, well, let's do another thing. Let's show what data is the one that satisfies it. Well, what data are the outliers? So let's use the data frame model dot label. So we know that if it's equal to -1, they are outliers. So this should show. Let me see what's labels here. So we see which are the outliers: 1, 2, 3, 4, 5. We have an other Virginica species. So let's do some graphs in order to visualize how the dots and the scatter of the data see after applying this algorithm. So that's we're going to need receive params. That is just for setting the graphs as a global configuration of graphs. So we just don't have to give the size each time we want to make a graph. Figure.fix size equal to let's see, 5.3. Yes. Why? Just because. Yes. Maybe. No. Let's put 10. 5. Yes. Let's see. Now let's call a seaborn graph. It's sorry. It's a seaborn parameter that it will show a certain style of graph. Yes, without problems. Now we just let's graph the original scatter plot of the iris data set without any dbscamp algorithm applied. So that's why we just use a new variable outliers, because we don't want to the iris disappear, because we want to just use it for didactic purpose. So just let's see. Okay, yes, we can see how the data behaves. And we can see that it's a clear separation between each species of the flowers. but that's not too important here. What is important is here how this data see before applying the DB scan algorithm in order to find outliers. Let's see, let's do another graph. Axis. No, this is just for adding access to the graph from 1 to 1 and 1 to 1j. We want that the colors are based in the in the classification, in the labels. So this means it's going to be 3 colors, depending of what in what group is the data. For example, if it's 0, it's going to be, I don't know, blue or red, and if it's -1, it's going to be black or yellow. Well, now we can see that, or that's how the data. Now we just see that these blacks are the outliers. And how we know that, apart from the colors, is that there are like little concentrations that are outside the bigger clusters. So these are like lonely points, lonely concentrations, or low density concentrations. So now let's see what happens if we change some parameter from the EPS, from the DB scans. Let's change the EPS. If we create a shorter distance, it will mean that that points needs to have to be really close in order to be part of the same neighbor or be neighbors. So let's change to 0.1. Let's see what's happened. And yes, all appear as outliers because the distance is so small that between them there are like this itself a neighborhood. Each point is a neighborhood. So we here. So neither of them satisfies what needs to. Neither of them satisfies the DB scan. So other pieces as outliers because of the parameter is the distance is too short. So let's just change, and what's happening if we put 1? It should be no outliers though. Well, yeah, there will be 2, but there were less outliers because if the distance is so great, it's larger, and there is less probability that they will be outliers. Just the ones that are really separated between each others will be outliers. So let's just let's change it to the original value plus 0.8. And what will happen if we make the concentrations, the minimum density concentration 1? Yes, this appears as outliers. And what's happening if we make I don't know, the double. Yeah, the outliers change. All depends on reading the parameters. And there are various methods for calculate these parameters. This is really arbitrary, and this is based on how the dataset behaves, or how the initial scatter of the dataset. We can see here that the points are not too close, so we can see that they have a really long distance between them, here from here, and even between the same group. So 0.8 is a really good distance. And the concentrations, it depends on also in how the data behaves, but this also is, here we just choose arbitrary. Well, now that we have played with the values, well, there's something important about this. This is really depends on the dimensions of your data sets. It means the variables. But some blogs say that the minimum, for example, that your DB scan should have is 3. Below that, it won't work as intended. But also, if the grader this value the best, so it will be more precise. It means that it will need more points in order to create a density area. So let's check what happened. Yeah, also we increase the outliers. So yeah, it's more or less play with these values when practice and see how it behaves. Yes, with 15 we have that. With the double, we have some values here and here and here. Well, that's all. If you have any doubts, don't feel free of writing, because this video is really bad. So let's see go to see a real tutorial.